Hello, welcome friends. Welcome to this YouTube channel, Shri Tech Education. Through this channel, we are giving you the information regarding various technical subjects. For today's discussion, we are again discussing on plastic processes for thermoplastic and thermosetting plastic materials. For today's discussion, we have taken this rotational molding process, which is again generally used for processing thermoplastic materials. So through this animation you can observe that what are the different processes which are occurring during rotational molding process. Before that, I will like to tell you these processes are generally used for making a large water tanks. You will always wonder how these water tanks, syntax tanks are made up. These are made up of this rotational molding process. Again, this process can be used for making luggage trays, flower pots, rainwater tanks, road cones, isn't it? And the material preferred for this is thermoplastic material, such as polyethylene, polypropylene, any kind of material you can prefer for processing by using rotational molding process. So first we will see what is this process. Through these next four processes are there generally in the rotational molding process. First step is the mold is open and it is filled with the powdered polyethylene, polypropylene or any thermoplastic material. It is closed and then it is transferred to the second stage where it is heated up to 300 degrees Celsius and it is rotated. That mold is rotated inside that heater with a moderate speed, not too much high, at a moderate speed, not too much low as well. It is rotated in both direction, horizontal, vertical, in n number of direction you can rotate this mold. During that process, what happens, that powder which is poured inside this cavity will get heated and will get expanded due to rotation process and attached to the mold cavity boundaries with a very small or thin layer, and that layer smoothness or layer finishing will depend on your finishing of mold cavity. Here the actual finishing depends on this mold cavity finish. You can get very high quality smoothness to these components as well. In third step, that mold cavity is again passed into the cooling section where again this mold cavity is cooled by using some cool air which is blown around the mold and aired by large fans. The mold cools slowly and solidifies. This solidified product in fourth step or last step, it is removed by ejection process or it is taken out by moving two mold halves apart, and you will get the component of exact size and shape as that of your mold cavity. Next we will observe it through one animation. That plastic raw material is placed inside this cavity. It is rotated. By this rotation it will get the shape of this mold cavity, isn't it? Again you can observe through this different colors of this mold cavity. First mold cavity is cool, that's why it is having some different color. After heating it has acquired some different color. Then it is rotated, again heating section, then it is cooled slowly, then the component has been solidified and it is removed from the mold cavity. Same you can see this through this diagram. Primary axis, secondary axis, it is rotated about both axes and you can get the component of exact shape and size of this mold cavity. The materials preferred for this rotational molding are nylon, ABS, polycarbonate, high impact polystyrene, again polypropylene, polyethylene. These are the examples of material which you can prefer for rotational molding. Then what are the advantages of this rotational molding? Since it is a low pressure process, molds are generally simple and relatively inexpensive. Also, the molded articles can have a very uniform thickness. and can contain reinforcement as well. You can add some reinforcing materials in between to get higher strength as well. And these are virtually strain free, and their surface can be extruded if required. This is also a good advantage. The use of this molding method is growing steadily because although a cycle time are slow as compared to injection and blow or extrusion molding, it can be producing a very large quantities, a thick walled articles which could not be produced economically by any other technique, isn't it? A large thickness components are prepared generally by rotational molding process of large size hollow parts. Next advantage, wall thickness of 10 mm are not a problem for the rotational molding articles. It can be used to make a part in sizes and shape that would be difficult by any other process. Changing colors during the production run is comparatively easy, whereas in injection molding and blow molding it is costly and time consuming. These are the advantages of rotational molding. Disadvantages: the part must be hollow. Whatever you are preparing, it will be prepared hollow only. No other complex geometries you can prepare. It is difficult to get a varying wall thickness within a part. Within a part you cannot get a varying thickness. A constant thickness component of larger dimensions you can prepare. So the parts are often designed with a reinforcing ribs to stiffen flat areas. These are the couple of disadvantages of rotational molding. So thanks for watching my videos. Like and subscribe my channel to get further videos on various technical subjects. In next video we will discuss regarding some processes to process the thermosetting plastic material. Thank you.